Hello, this is simply about networking protocols, and today we'll talk with you about topology router on a stick. In this video, we will discuss this topology router on a stick, discuss how inter-VLAN traffic being processed by this topology, intra-VLAN traffic between different VLANs, external traffic processed by this topology, and some tips and tricks, how it works, what is interesting about it. So, router on a stick, if you look into Google, into any search that you can apply, you will see basically a scheme like that. So you have some subnet LAN in one VLAN, subnet LAN in another VLAN, entry to external VLAN, and router basically on a stick connected to this switch. It is not very canonical to connect external one to switch, but okay, let's stick to this topology, and later I'll display you that there is no difference for topology is one connected to a switch or to a router. So, inter-VLAN traffic. As you remember from previous videos about stages of traffic processing and priorities of traffic processing, traffic is being processed, each frame from the traffic is being processed step by step and hierarchically by levels of OSI model. So first it goes to L1, then L2, then L3 if applicable, then L4 if applicable, so on and so forth on enter, and on exit same, downwards L4, L3, L2, L1, and run anyway. So inter-VLAN traffic is processed on L2 by VLAN only. Each end station sends the traffic to a switch. Switch by FDB defines where to send this traffic away within the same VLAN, detects exit interface, exit port, and sends it to destination end station. And this is true for all VLANs, for any VLANs, for inter-VLAN traffic. It's being processed on L2, single bar switch without complex interactions. Everything is fine. But what if we need to send traffic between stations in different VLANs in different subnets? Okay, as you remember again from previous videos, this traffic should be defined by IP. So end stations identify itself by IP addresses. This IP traffic is being sent to a switch within VLAN. Switch doesn't have in this VLAN address for this end station, but it sees that traffic is IP and sends it to router for processing. Again, in this case, you can see that all switch ports are members of a single VLAN in case end station is connected, but port that is connected to router and router port that is connected to a switch needs to be in Cisco terminology trunk mode, in some different vendors general mode, member of multiple VLANs. All VLANs that we planning to send traffic intra-VLAN needs to be presented on a port that connected switch to a router and router to a switch. Not simple yet. And then further. So again, traffic is being sent to router. On router, we already have routing information for sending traffic to end station in different subnet, and routing happens intra-VLAN routing. Traffic is being transferred from VLAN green to VLAN blue, let's say. Sent back to switch tagged with new VLAN by FDB and all on L2 level, on VLAN level. Selected port from which this traffic needs to be sent out to the final end station, and it's being sent. So pretty simple. The thing is that routing happens on the router, and switch continue working on L2 level, on VLAN level only. External traffic basically works the same. So traffic identified by IP is sent to a switch. Switch sends this traffic to a router with an VLAN. Router, by routing information, routes traffic to different VLANs. So basically, remarks tag on the frame, sends it back to switch, and switch sends it in the VLAN, sends it to one. Backwards happens the exactly same paths, only opposite direction. Very simple. In the VLAN, within the switch to the router, there happens routing and remark traffic to different VLAN, goes to a switch and goes to the necessary end station. Very simple. So, why do we need this? Basically from economical reason, because router port costs much more than switch port. Anyways, all end stations need to be connected to individual ports on the traffic transfer device for better manageability of the interface on the subnet of the end stations and so on and so forth. Mostly traffic is running within VLANs. Some traffic needs to go externally or to different VLANs, so basically we should be okay. But what if not? What if possibly can happen that it will be much more traffic, so single port will not work? Similar to the real life, if small stick doesn't work, take a thicker stick. This is not a canonical name, don't Google it, it's just for, imagination. Simply create a port channel that will join in a single interface multiple ports on switch and router. Anyways, from port usage point of view, it will be much cheaper, much less router ports will be used in this topology, and eventually you can put on a stick, you can put router on as many sticks as you need from your network topology point of view. And going back, talking about one connected to the switch in this topology, if one will be connected to router in same topology, it still be router on the stick, because intra-VLAN traffic will run by the switch and that's it. Inter-VLAN traffic will run to router and backwards to necessary end stations, and external traffic will run to router, to one, to external board and backwards. So from the stages point of view, it doesn't matter at all. Even for any reason you have multiple exits to the external board, or in case those ones are not actual external board by some additional intermediate, layers of your topology between subnets and external board, whatever, everything works in the same way and very similar. That's it. Thank you. Have a great day.